So it's often helpful to identify what type of equation you're dealing with before you start trying to find a strategy. And that involves thinking about all the different ways you could rearrange. Look, that x is next to a parentheses, so that could distribute, right? So that's going to be x squared, and that's going to be an x. So a square, the 2 is the highest power. That means this is quadratic. And same thing with this is quadratic, and this one's clearly quadratic because of x squared for the highest power. So if it's quadratic, we always want to solve by setting it equal to 0 first. Okay, so let's distribute this x first to break down that parentheses. Well, here the big idea, the big motivation is that we can't solve. It's factored, that's nice, but we can't solve because we're supposed to set it equal to 0. It's set equal to 56 right now. And if you subtract 56 from both sides, the whole entire side needs to be factored in order to set each factored piece equal to 0. You've got to figure out what it would take to make this equal 56 in order for 56 minus 56 to equal 0. So that's a tougher problem. But let's expand this by distributing that x. And now let's see if we can solve this. You can solve with the quadratic formula, but let's see if we can solve by factoring. So we want to see if there's two numbers that can multiply to be negative 56 but add up to be 1. Oh, I got it right there. 8 times negative 7 makes negative 56. 8 plus negative 7 makes positive 1. So this is a separate problem. So I'm going to make two parentheses. I'm going to put a plus 8 and a minus 7 here because those two numbers multiply to be negative 56. Those two numbers add up to be positive 1. And now that this quadratic is entirely factored on one side, we can set it each factored piece equal to 0 and solve. Okay, so if you solve this one, you get x equals negative 8 and x equals 7 from this one over here. That's our two solutions. Okay, so if you were able to follow that, now you think you know what to do. Pause the video and try to do this one without me. Okay, but here I go. X times x makes x squared. X times negative 4 makes negative 4x. It's quadratic, so I'm going to set it equal to 0. I'm going to subtract that 12 from both sides. And now let's see if I can factor. Oh, I don't know if I made this one factorable. Can I find two numbers that multiply to be negative 12 but add up to be negative 4? I don't know if anybody can do it. It's better be the math teacher. Yeah, negative 6 times positive 2 makes negative 12, right? And negative 6 plus positive 2 makes negative 4. So that's two numbers that multiply to be negative 12 but add up to be negative 4. So we're able to factor it, and then we set each factored piece equal to 0 because when you do that, you're finding out what it would take to make that whole left side equal 0. So solving that one, you get x equals 6. Solving this one, you get x equals negative 2. You can plug that in. You're going to get 0. And right here, negative 2 plus 2 makes 0, and 0 distributes and eats everything up and makes it be 0. Or you could just plug it back into the original equation, right? And then so this is the last one I made up. Same type of thing. It's quadratic, so we're supposed to set it equal to 0 first. And then solve by factoring. X plus 2 and x plus 2. Two numbers are multiplied by 4, but add up to be 4. And so that's the same thing squared. You're going to get x equals negative 2 for a solution here. But remember, if you can't factor, use the quadratic formula. There's always a way.